Alright, welcome to part 4 of my little video series on quick intro to PCB design. If you missed somehow the other parts, this was based on lectures at Dalhousie University I'm doing for an undergrad class, so I decided to record a few quickly. So in this part, I'm talking about prototype bring up. So once you get the boards back, how do you actually solder them up and bring them up? This part is again something, it's a lot more fun hands-on, but as part of the lecture, have some slides recorded, so I thought I'd share them here. So basically, the core part of bring up is going to be soldering boards together. So we looked at how you could get boards pre-assembled. So you could get them pre-assembled as one option. Or if you have some soldering experience, you should be able to build up your prototypes, pretty well. And I'm going to talk about different ways of doing that. Again, one emphasis here is design for what you can do. So if you've never done surface mount before, maybe stick to bigger surface mount parts, right? Don't go straight to 402 or QFN parts if you've never touched it before. So the point here is that you're going to have a lot more success if you follow what sort of experience you have when you design your boards. If you're doing surface mount for the first time, there's lots of good guides and information out there. It's been quite a few years since I looked at all of the guides available, so I'm actually going to reference my own guide that I wrote quite a while ago. But there's lots of other great videos out there showing you different SMD techniques. You're often going to use something called solder paste that we'll look at in a second, but you can also do it with regular solder. Now there's one big important caveat here. If all you've done is through-hole solder, you might have just used wire solder. Let me put some wire solder here behind me. Soldering station. Right, so we have some wire solder, and with wire solder, you have a little bit of flux inside it. What you also want, though, with surface mount is some little liquid flux that'll look like this. So this is a chip quit liquid flux. This is going to be absolutely key for any sort of success with surface mount soldering. Don't rely on just the flux that's in the solder. It works fine for through hole. For surface mount, we're going to need additional flux. We're going to be reheating solder that's been exposed, and you need the cleaning action of the flux that happens. So normally when you're using through hole soldering with this, right, as you're soldering, the flux is cleaning the joint and giving you good wetting. With surface mount, we're often going to be putting solder down first, and then getting the part in the right position and then reheating it. So we don't have the cleaning action on both sides of the joint. So it's critical that we have external flux. You are really going to have a hard time if you don't. Also buy good quality. If you get, I know many people that have thought they were terrible at soldering because they bought low quality solder off Amazon, and the metallurgy is all bad. So cheap out on your iron if you need to. Do not cheap out on your consumables like the flux and the solder. Get very high quality material for that. It is well worth it. So this is from 2003, which is a scary amount of time ago. So I recently uploaded it because it was on a website, AVR Freaks. So there you go. So there's a little guide from AVR Freaks I wrote for this website. Still is about AVR microcontrollers, but lots of other Atma ones. So there were some examples in here, typos included, of different stuff that you might like, solder wick, flux, things like that. And so I don't know if some of this has changed. This is a really old iron that I had at the time. But it goes through some of the different information about surface mount soldering and identifying the parts. So it's still pretty useful. It also talks about different ways of doing surface mount soldering. Some of these packages aren't as common now, so this PLCC package isn't as common. And it goes through some different sort of advice on that. And even here I have flux, so this is in a pen, so rather than this little standalone flux bottle, I've got a little pen of flux, and again, that's really helpful when it comes down to getting flux on the board is super critical. Watch out what type of flux you use. So there's some types, like I think I might even reference them here, like an RMA. Let's go up here. There's an RMA pen. This flux you have to clean off. So if you're not going to do a cleaning process, use a no clean. So no clean flux. should not be active enough that it'll attack your board. Flux is basically an acid. That's how it does the cleaning action. RMA flux you must clean off, otherwise it's going to corrode your board if you leave it on. So that's kind of, again, goes through some of that guides there. So this talks about all sorts of different stuff that might be helpful for you. That's with using through fixed solid core, or not solid core, solid solder, flux core normally. The other thing you can have is solder paste. What this is a bunch of solder spheres, and it's suspended in sort of a flux effectively. So you have both flux and solder in this paste material. One important caveat of this is you can imagine that flux, as it heats up, it gets more liquid. If you heat this thing up too much, what's going to happen is those spheres are going to separate out. So a lot of the solder, you have to keep it at low temp. It has a shelf life because the flux evaporates slowly. So it becomes a lot harder to work with. You'll find old solder paste doesn't work as well, gives you issues with balling up. So that's the downside of it. But you can get it in tubes like on the left here, and tubs as well. If you're doing solder paste, there's different ways to use it. Most common is with a stencil, but we can also use solder paste and paint on the pad. So I'm going to pull in some videos to show you how that works. So some of them are mine, some are just I found on YouTube. So I'll have links to them below. So I posted a big example. This isn't really a tutorial. This is just me showing you what does a full hand assembly look like. So there's a link to this blog post, and it has some of the details of the tools I used. So you can check it out if you're interested in it. It talks about the stencil process. So the stencil is how we put the solder paste over. It goes in the pads, and then we heat everything up. The video itself, you can go check out, right? But I go through from stenciling to placing the parts, and I'm using a little vacuum tool to place the parts, and combination of vacuum tool and tweezers, and then just going through and looking at all of the stuff. And finally, I'm using a reflow oven to run it, just a little tabletop reflow oven, but there's other ways to do this too. So the other way you can do this is with a skillet. So this is, an electric frying pan. Basically, you have your frying pan, you put your PCB in it with the parts on it, and it heats up through the PCB and melts the solder and reflows it. So this is a really good way. It actually works quite effectively. I've done this in the past myself. Buying a skillet's pretty low cost, so it's nice that way. You want to design your board. Again, design for what your process is. Design your board so there's no parts on the bottom side. Makes it easier. And in this case, in this video, I'll just link it. I won't pull it up, but he paints on the solder paste with a toothpick. So this is a good example there of doing that process. So this is a really easy process. If you paint it on, the other thing you can do is a hot air gun. So I have like an older hot air station here. You can get cheap ones from Amazon. And you have a gun, so you basically set this up. You set this, and I tend to set it so that it'll brown paper. It'll be pretty hot, like around 400 Celsius. Magnet over there. 400 Celsius. And you'll want the paper, as you bring it along, you'll find that it's kind of browning the paper is about the right temperature. I use that as a sort of general test, but you can see lots of good videos of people using hot air reflow stations on YouTube. The nice thing about that is this is really good for repair. So if you need to take parts off, we take the hot air tip and we heat up everything, and then you can pop the part off. So that's one of the advantages of investing in a hot air gun. As I said, you can get them really cheaply even. You don't have to have a very fancy station for that to work. And yes, start around 350 to 400. See, I'm mostly using lead-free solder, so you could adjust that a bit, but that's a good starting point. And again, golden rule, keep bringing it up here. General bring up best practices. So let's assume we know how to assemble it. When I'm building a board, I'll often assemble small, depending on how complex the board is, I might assemble small portions at a time. I might test the power supply. So if it's a big FPGA board, I might just build up the power supplies on one board, and I might do this just on a board that I'm not even assembling further, and check that the power's coming up, everything's looking good there. always use current limited supplies if possible. Some boards need a lot of current, and it's very hard to actually do that safely. You kind of end up just having to hope, right? So anything that's driving a big load, you can do some basic tests, but until you put the big load on it, you can't really do a test without the big load. And do as much as you can. So sometimes this might mean jumpering off to power down parts of the board, or leaving resistors off if you have parts of the board separated. So if you have a high current or high voltage mode, avoid triggering that until you're confirming everything else is working. The other handy thing is a thermal camera. So you can get thermal camera add-ons for your phone, like the Seek Thermal, and there's other off-brand ones too. But this can be really helpful. So here I'm actually testing sort of some transistor temps, but this is a really good way. I use this all the time for the first power on. It'll catch stuff like, I undersized a resistor, or things that may not even be super obvious, but on a complex board, it's really good. You'll see right away if something seems like it's getting too warm too fast. You're going to need to fix stuff, so don't worry about that. That's going to happen. Normally, operations are cutting a trace and rerouting stuff. You can get fancy equipment for this, but I tend to use just a drill bit. Works well to cut a trace, so you just hold that on your finger and spin it. And you'll need to scrape pack the solder mask, and then we can use something that we normally call bodge wires. So these are little wires. So here's an example from someone that was doing a repair I just pulled. And these are little wire wrap wires often. So it's a quite high temp coating, or you use something like a magnet wire. So I have a spool and my spool is breaking here, of magnet wire. The key is you want something that has a low temperature insulation. You can get magnet wire with a high temp insulation, good for building a motor where you don't want it to all short out. But if you get low temp stuff, you can actually just melt the insulation off with a soldering iron. So places like, I think SparkFun and some Adafruit maybe, they sell little reels of this too. This was from a bigger reel I had. But magnet wire is also used for bodging a lot. But you just need some fine wire. Ultimately, like 26 to 30 gauge might be used, and you could use higher, if you need, but that's a good starting point. So that's about it. So that was, the initial 4 parts of this intro to PCB. As I said, this is kind of taken from a introductory lecture, so there should be a lot more hands-on, but in the university lecture, we don't have that. So hopefully it's still been useful. There's a couple little add-on videos. I know it said 4 parts, but I'll link. There's sort of some bonus KiCad setup stuff I did. One big thing is just don't get overwhelmed. Make mistakes. Send boards out. They're cheap. Do lots of boards. I will also say that online you see a lot of people being, I would call, overly pedantic. I've designed hundreds of boards, as I said. I've done a lot of different designs, complex, not complex. And I see people really worried about things that just don't matter ultimately. They do matter, but when you're doing your first board, it's not important to worry about yet. Just get things down. Do a lot of experiments to understand, hey, is this trace too thin, too thick? You'll get better at it. My first boards were pretty messy looking. They weren't very pretty. They had issues. So it's good to take advice, but don't stress out when people are talking about all of these things that are applicable to high-speed design, impedance matching, all these things that you probably won't care about initially. You can get away with a lot of pretty, quick and dirty design work, even for prototypes, right? Even if I'm prototyping some moderately high-end things, I'll do some pretty quick design tests because I'm just doing a board. It's not passing FCC. It's for my own testing, or EMC testing, anything like that. It's for my own purpose. There's very different purposes, and when you look online, I find you often get people that are talking about, hey, this board's being done for a big run. It's got to pass a bunch of tests. It's going to be a consumer electronics. They're super worried about cost optimizing versus I just need a board to test something. So yeah, ignore the advice if it seems overly pedantic is what I would give you that advice as well. And hope you have a lot of fun with it. And if you make any boards, post a comment. We'd love to hear that this was helpful for people.